Kaboom. Here we go. Get out of here. So, I forget what they were already, right? The red curve was 1 minus cosine. Obviously, plus. And the green curve? Minus? I knew that. Okay. So, what matters is, and now this is between these curves, okay? So I want you to think when you see between, you're going to be using addition. Because we're going to integrate one until it stops, and then the other one starts. We're going to add those areas together. But when you see the words outside one but inside the other, you're going to use subtraction, because then we've got to subtract something off. All right? So what we need to worry about here is, and I always start at 0 and kind of wrap around in a circle here. But look, let me change colors here so I'm not, this stupid window. Get out of here for a second. Let's switch to, okay. You think blue? Blue's a good one? Blue it is. Blue. Okay, let's go back out. Boom. Okay, starting at 0, we're out here. Do y'all see that? What curve is that on? We're on the 1 minus sign. And as theta wraps around, it's going to wrap around on this green curve until we get to the origin right here, right? Now the green curve wants to continue going around to pi, but we don't want that area. We want to hop onto the red curve after that. Okay? So we need to integrate the green curve from 0, which is right here, to where it hits right here, which is going to be what angle? Pi over 2. Now the reason why we know it's pi over 2 is not because it just jumps right down in there, because it could have a loop or something negative down there. Okay, you got to look at the equation here and see what's going to make that 0. When is it going to hit the origin? And it's going to happen when sine equals 1, which is at pi over 2. So we need the green curve from 0 to pi over 2. We okay with that? That's the bounds on that to begin with. We're going to hit the green curve again. And then we're going to start on the red curve. Now here's the problem. Although the green curve hits the origin at pi over 2, the red curve does not. Okay? The red curve hits... Now we need to start right here and wrap around here. Do you see this? But that's not going to be from pi over 2. And that's the problem with polar curves. Just because they're at the same point doesn't mean they're at the same angle all the time. And the main problem is the origin. If they're hitting each other out there in like a quadrant somewhere, then they're either at the same angle or 100 degrees off, or 180 degrees off. Okay, but if they're hitting the origin, then it could be any angle. So you got to worry about that. Where's the red curve going to hit the origin? At pi. At pi. And if you're having trouble seeing that, look, let me erase this junk. Just go back to the red curve and trace it out a little bit. It starts here at 0. It wraps around here. Here it is at pi over 2, right? It's at 2. Okay? Or at 1, I mean. We're counting by halves here. And then it goes all the way around the pi, and then it hits 0. Cool? So the red curve, we need to start at 0. Not at 0. At pi. And we need to wrap around on that green curve there, or the red curve, I mean, until what happens? Until they intersect each other. Okay? Now, because that's out in the fourth quadrant, that either has to be an angle in the fourth quadrant, or it might be an angle in the second quadrant. Randomly, it usually is not something weird like that, where both r's are negative. Okay? But we don't need to worry about that really too much. What's it look like they're hitting each other at? It looks like it's at the 45 degree, the pi over 4 there in the fourth quadrant, right? Which is 7 pi over 4. Cool? If you didn't know that, a lot of times in the AP test, they're just going to give you that. They're going to say, hey, they intersect here. If they don't, then you probably have a calculator, or you've got to set them equal to each other. Okay? I don't know. There's a lot of stuff that could happen, but I showed you this with tracing this. We could go in here and graph both of these. 1 plus cosine theta and 1 minus sine, right? Okay. We don't want to do that. Boom. Cool. And now when you graph this, the window's going to be a little bit too big. Okay. What did I do? Oh my god. Great. What did I do wrong? Oh, there's too many parentheses. Here we go. Okay, we want to know where they hit each other, right? So I'm just going to trace one of them. Remember, I set my window theta step to be pi over 12. So all I got to do is count around until when it hits it. Okay? Now, if it's a big angle, it's going to take a while, but we can still do it. Look, we're at 0 pi over 12 right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay? 21 times it took to hit that. This is a very basic way to do this. I don't think this is the best way to do it, but if you're stuck, you should do this. 21 pi over 12 happens to be 7 pi over 4, which is what we thought it was going to be anyway. Okay? Alternatively, you can just set them equal to each other. Again, you want to know when do they hit each other. That's going to be when is, oh my god, cosine 1 plus cosine theta equal to 1 minus sine theta. Well, that only happens when cosine theta is the opposite of sine theta. And everybody knows that happens at 3 pi over 4 and 7 pi over 4. Okay? So, either way, we got to integrate that red curve until 7 pi over 4. Cool. Okay. Yo, the 3 pi over 4, by the way, when they're the same, is up here. They're hitting up there again. We don't care about that point, but that's why we're getting two answers. Because they hit each other again in the second quadrant at 3 pi over 4. Okay? And then we got to do the green curve from 7 pi over 4 to 2 pi. Okay? And we're adding all of those areas up. So what this is really going to do here, the first integral we do, which I'm going to do in blue, this has some symmetry to it as well, so we can kind of reduce this down a little bit if you think about that. But if you're unsure about whether or not it's symmetric, just do the whole stupid thing. The first piece we have to do here then is, oh my god, it's a triangle, is a half the integral, and we're going to go from 0 to pi over 2 on the green curve. Now, if you're writing this out on the AP test, or you're writing it out on your paper, you can call these like R1 and R2. So that way you don't have to write them over again. You can just write R2 squared. Okay? And for simplicity's sake, I'm going to write out what we're doing in full. But you get that. That's going to find this area right here. Cool? The next thing we're going to do is 1/2 the integral from pi to 7 pi over 4 of 1 plus cosine theta squared. Okay, and that's going to find, let's use a different color here. We have so many options. Do I have other options? Where are my colors? Let's do the color wheel. What do you want to do? Orange? Orange is good. Great. Okay. That's going to find the area here all the way. Remember, it's always from the origin. It doesn't, like when we did function mode, like integrals of f of x's, that does from the function down to the x-axis. This always does from the polar curve into the origin. Okay, so it makes little slices of circles, not rectangles. We said, yeah.
Why is it
7 pi over 4? That's a 4. Yeah, because I'm super sloppy. That's why. That's a 4. Okay, and then the last piece, which I'm going to sketch out in, I don't know, let's do green. Okay, that's right here. Whatever. When we do green, that's going to be from 7 pi over 4 to 2 pi, but on the red curve, or the green curve, I mean. So we have to add to that 1/2 the integral from 7 pi over 4 to 2 pi of 1 minus sine theta squared d theta.
Why are we finding like a really, really tiny sliver?
Where?
On the top left, like.
It's a good question. You think they want us to find that little tiny area?
I would say probably not, but like it's there, so that's why I'm asking.
Man, you're right. I skipped over that whole thing. I wasn't thinking about that. So, okay. It's a small change. We can do this. Good call. Yo, the green curve actually goes out to here. Sorry. So instead of integrating to pi over 2, we're going to have to integrate from 3 pi over 4. I mean, 2 3 pi over 4. Sorry. Yo, we need, look, time out. Okay, look. Complaining about this is not going to help. I'm sorry I missed a little piece. Look. We did the blue curve, right? Or the green curve, I mean, the blue piece, from 0 to pi over 2. But the green curve continues right here, and I wasn't counting that little tiny piece. So we actually got to integrate until where they hit, not to where it hits the origin, which would be 3 pi over 4, which we found by setting them equal, or by tracing them. Okay? Small thing, which means this isn't going to be pi over 2, it's going to be 3 pi over 4. Cool? It also means then we have to start the other curve earlier, too. They don't usually do that where you got that little tiny weird piece. It's usually just one kind of easy thing to see. Okay? And I'm going to show you some AP stuff. Hello.
She's looking for someone else. Did she even say hi back?
No. What time does class end? Oh, 34. Okay. Yeah, 104, but we have lunch in there, so we ended at 34. Okay. All right. Yo, do you guys understand why I'm changing this? I didn't see that little tiny sliver in there. Okay? And then we got to go from, on the other curve, not from pi, we actually have to start at 3 pi over 4. That was a good question. Sorry about that. Okay? That's just because they intersect out there. Oy. All right. Cool. Usually, though, let me show you like an old AP question. They usually make this a little bit easier for us to find areas like this, okay? All right, so let's stop this here.